Okay.
Talk to me.
So I don't know how to start. When it says positive first derivative and negative second derivative, on the Danica's chart or whatever, I would circle like the increasing, right? And then concave down.
So I circle both
Yeah.
so I can see the correlation.
And then the negative second derivative, you would do that. And then would you find the slopes or like the
Secant
difference?
slopes.
Yeah.
And make sure you say secant. Yeah.
Secant, okay.
So what's the secant slope from here to here?
2.
Always check the x. So I have the habit of doing 2 over 1,
Oh,
just to make sure I don't forget.
okay. And then 3 over 1. And then 4 over 1.
It's that you want to always on a calculus problem want to think as you go. You avoid autopilot where you're just like, oh, I always do this. Just think as you go. So does that tell us anything?
And it's increasing.
What's increasing?
The secant slopes are increasing.
Right, the secant slopes are increasing. What does that tell you?
That's could be a value of at.
I'm not sure you mean by a value.
Or like, so you're trying to find the table of values for f.
Oh, right. So could this be a legitimate f function?
Yes.
The answer is no. Because what are so f is concave down,
Okay.
which means if you follow f
Which means it's increased.
from point to point like this, if you go from secant to secant, so watch what happens. So if I go from this secant to this one, do the secant slope values increase or decrease?
Increase.
So is this slope positive or negative?
Positive.
Is this one positive or negative? Okay, so I think you're mixing up a little bit what Ari was doing. This line is increasing, like the blue line goes up, but that's not what we're referring to. We're referring to the secant slope's value. Is this secant slope's value positive or negative? Still positive. How about this one? More or less than the first?
Less.
Less. So the values of the secant slopes go down
Okay.
when the curve is concave down.
Okay.
That D reminds me of that.
Yeah. Okay.
Because we talked a minute ago that the D here has 2 meanings. So back to this picture. Come on. Where did it go? Come on, dartboard. Oh, you just made this really cool picture. Well, it's way back on that other one. Shoot. Hold on, just give me a second. Too excited now to quit.
Persistence.
Persistence, that's
Look,
right.
look, it's full circle.
Persistence. There it is.
Yeah, that's one thing I don't really struggle with is persistence. In fact, I have to tell myself to quit because I don't give up easily. Had a student one time, he kept asking questions, and he said, well, it's like 4:30, don't you need to go? I'm like, well, do you understand it all yet? No, we'll stay, it's okay. 5:30, he's like, Mr. Smith, it's 5:30, you said you're leaving at 4:30. Your questions aren't answered yet. Okay. So. Okay, back to the other place, hold on. Which number is it? Please help me again, Candy.
18.
Thank you. Got an alarm sounding somewhere.
Isn't that the vacuum thing?
Oh, probably.
Yeah.
The vacuum man.
Vacuum man.
He's out to get us.
The vacuum man.
It's an inside joke of some sort.
Nope.
Very outside. Maybe it's a good thing we don't calc together.
I was thinking I had touched on
The
you.
thing is, Liza sits over there and I sit back here and calc. So
Do you
The whole
sit
class
by
can hear me.
Colin and Ash?
Oh, yeah.
Oh yeah, they all sit.
up there, and I'm back here, and I can still hear everything.
Sorry, Kennedy. I
Kennedy's
forgot to
the
hit pay.
best Calgon buddy in the whole world. Me and Kennedy Calgon. Everyone wants
Me
to
and Liza.
be Kennedy's Calgon buddy. A1,
One more try.
Wait, when do you have Cal?
April.
It's not working.
This is devastating.
Hold on. Everybody just keep laughing.
Ha ha ha
Nothing?
Yeah.
Wait, so today you said it's like typical for us to only have like one test per term, is that correct?
That's not typical, that's what it is, so.
That saves me
Well,
so
So
much.
we only have 4 tests.
3.
3,
Oh.
3 and the AP?
and then we start practicing for the AP test.
Wait, then what do we do after?
Rigorous academic activities.
You sound like Pharrell.
I stole it from him, so I have to give him credit. That was not my idea.
Scott Farrell is a god.
Scott Pharrell was the
No,
best.
I'm serious. That one day when he gave us a hug, I didn't know what to do with myself. I was like, giggling.
Okay, do you want to hear something? You know Sarai?
No.
So
Yeah, Wilding,
she was
yeah.
sitting next to me today when we were sitting in your class, and she leans over to me and she's like, "The devil works hard, but Craig Smith works hard." He was laughing so hard, and I was like, "It is so true."
The devil works hard, but Craig Smith
But like
works
in a
harder.
different way. But I mean, it was so
That's
funny.
super nice.
That is very nice.
Not funny.
That's a different compliment.
No, it was.
It's a good
Do you
compliment.
ever eat?
She meant it as a compliment, not
Yeah,
as
You
like
just like starve
So
August through May.
August through May.
That's what June and July are for.
Yeah, you go on like
That's right.
Hibernation storage and prep for, this 9-month journey. That's fun.
Craig Smith is a bear. He had
So I had to tell you a joke on that one. So I haven't done this for a while because it just hasn't worked out. But there were a few years where I would kind of, in a creative way, kind of hint that if you showed up at my house on Halloween, I would give you a really nice Halloween treat.
Thank you. My brother did that. He came to your house.
Yeah. So I've struggled to do it recently just for various reasons,
Me and
family.
Miranda and Liza.
Stuff like that. But anyway, so one time I had some kids show. Actually, I had a lot. One year I had like 80 show up.
Well,
So so one year somebody walks in the house and like I'm giving them a nice treat and everything. They're like, they look around and they go, "Oh, this is the kitchen." And they're like, "This is where he eats."
Wow. He has a family?
Yeah, exactly.
What?
Surprised everybody, So. Hey, it worked. I don't even know what we're talking about
remember that
now.
though. I remember my brother coming home and he's like, "I just came from Mr. Smith's house." I was like, "What?"
All right, here we go. So look, the D, man alive, that was a long time. So the D has 2 meanings. If you're looking at the graph of F prime, so right here, pay attention to this section again. This is the section where F is concave down. In that section, the y coordinates of F prime will go down. That's the meaning of the D. The second meaning of the D is if you follow the curve of F, and you pay attention to the values of these tangent slopes, like Ari was saying, it's not that those slopes have a downward trajectory, these have an upward trajectory. But the values, as we go from tangent to tangent, they decrease.
Would that just be like, oh no, not negative because it's still up.
Right, look, positive, less positive,
Yeah.
negative, more negative, more negative.
Okay.
That means as I went from tangent to tangent to tangent along F, I saw slopes that decreased. So the D has two meanings.
Okay.
So in this problem, the meaning we're using is we follow the curve from point to point. The secant slopes must also decrease in value. These secant slopes are increasing in value.
Okay, so we need to find some that's like 432 or something.
Yeah.
Oh, okay.
So this is a concave up curve.
Okay. Oh.
Wait, would D, since it's negative, like it's subtracting 2, subtracting 3, subtracting
So what's the secant from here to here, Ari?
4? Negative 2.
Over 1. Here to here?
Negative 3 over
Oh
1.
my gosh. Go ahead.
And then negative 4.
So are those secant slope values decreasing or increasing?
Decreasing?
Decreasing. From negative to more negative. So that's the right answer. Well, maybe. We gotta have this happening too. So both have to happen.
But C is going from negative 4 over 1 from negative 3 over 1 to negative 2. But that's increase. Because isn't it getting closer to 0, so it's increasing?
Yes. So this is wrong for sure.
Wait, why? Because it's getting closer to 0?
So if the secant value is negative 4, then the next secant value is negative
Oh,
3.
it's not getting smaller or decreasing.
It's not the values of the slopes aren't decreasing, they're increasing.
Okay. So what would you do after that? So it's
So
either like B or D.
what were the secant slopes here?
4, 3, and 2.
So we'll skip the 1 for a minute. So is that what we want?
Yeah.
Yeah, that's good. So it could be this one.
Oh,
Can it be
but
this
then
one?
11 to 7, that's,
Can it be this one?
no.
Secant slope is negative 2. The next secant slope is negative 3. Does that mean the secant slopes are decreasing or increasing?
Increasing. No, decreasing.
Decreasing. Negative 3 to negative 2 is a decrease. So it could be this one. How about this one?
No, it's just negative.
Oh, it's always negative 3. So we've got two choices. Okay, a smart thing to do in calculus as well is once you've done something, start over. Like just start the problem fresh. So talk to me some more. Like just begin again.
So you're just finding the positive first derivative and second, negative second derivative. So.
Talking, you're doing great. But this is a long video. Keep going.
Positive first derivative. So it has to be increasing.
Right, the function itself must also increase. All of our focus so far has been down here,
Yes.
which is fine, but we've got to make sure this happens as well.
How can it increase and decrease at the same time?
The
This is the
slope.
problem with using the word if. Yeah, it isn't increasing and decreasing at the same time, but I'll show you what's happening. So which one is it?
Are you asking like which?
Is it B or is it D? Okay, let me say it back to you. The clues are telling you that the y-coordinates of F must go up, and that the tangent slopes of F, or secant slopes of F, must decrease. So do these secant slopes of F decrease?
Yes.
When
Yeah,
it's talking
4,
about
3,
the y values of f, are you just looking at the f of x column? 'Cause
Right.
that would narrow it down to a to b, and since we already know a is out.
There you go. Yeah, that's why you can't use the word if. I don't know what it's doing, but the values of F are increasing. The secant slopes of F are decreasing.
Okay. So when it's talking about increasing, could it be the same as what we were talking about with the decreasing? Like, could it be talking about the secant slopes and the y? Or is it just
Of
like,
what? Y of?
F.
Okay, so let me point here and give you the summary.
Okay.
If I'm looking at this column, I'm only looking at y coordinates.
Oh,
This means the y coordinates of f go up, or the y coordinates of f go down. End of story. Like Ari said, this does not mean the y coordinates of f are positive or negative. Don't mix that up. This means the y coordinates have a concave up shape, or a concave down.
okay.
Okay, now when I look at this column, I have to remember two meanings. If f prime is positive, that means the graph of f prime, so f prime is positive, that means you're looking at f prime having positive y values. Like, for example, here to here. Got it?
Yeah.
That doesn't mean f prime goes up, that doesn't mean f prime goes down, that doesn't mean prime is concave up or f prime is concave down. It simply means f prime has positive y values. Good? Okay? But it also means that the corresponding graph of f will go up. Doesn't mean that f graph has positive values, it just means f goes up. So right here, when f prime is positive, f is going up. That's all it means. Down here, double meaning. If f prime is increasing, that means you will see the values of f prime going up. Right here. Here, f is concave up. Here, the y values of f go up. Some of those values of f prime are negative, some of those values of f prime are positive, but f prime is definitely going up. But the I also means that if you look at the f graph and follow the slopes along f, like we go to here, is that slope on f positive or negative? How about the next one? Less or more? Less negative. Is that an increase in slope value? From a negative number to a less negative number.
No.
It's an increase in slope value because this would have been maybe like negative 10, and this would be like negative 7.
Oh, yeah,
When I get to here, what's the slope?
0.
Are the slopes of f, so I'm looking here, are the slopes of f as I follow f, are they increasing?
Yes.
Yes. That's the other meaning of that. Has a double meaning. The y coordinates of f prime go up, but the tangent slope values of f also go up.
Okay.
Now look, one more thing. On this graph, you can correlate it really well because the y coordinates here are the slope values. So right here, I just come straight down and say, oh, about negative 30. So that's really negative 30. That's slope. Right here, right there, negative 15. I can literally read the values of the slope. Does that make sense?
Yeah.
Cool. Please.
Can we do 22 on the green copy?
Yes.